So from the LED status, it's not armed. Pay attention to especially this motor here and this one sometimes. So if I arm it using this one, look at the motors, you can see that it is spinning, but not very fast. And then this one is not. And when I of course it's armed. When I adjust the throttle slightly, now it's spinning, but the others are now way faster. Well, let me even push a little bit further, or maybe it can even stop. Just a small, yeah, just stopped. And if I push it more, the speed is too low. Of course, it does react to IMU. You see, this would be terrible if this motor stops completely at this angle. This one stops too. I don't know how bad this angle is, but this one stops too. This one will never completely stop.
Oh, what's going on?
No, because I
just
lifted it.
Just leave it down, and then can you like throttle a bit up so that we can see what happens there? Okay. Yeah, so this is really bad, like yeah. Okay. So let's start with the angles and know why this is happening.
All right. So ready off, right?
Minus your row is -4 and your pitch is minus what? 7?
About there.
If you hover on it, you can see
Put it down.
Can you hover on
the value here?
signals? Yeah, you can see the samples, the values, time, and everything. I really like this terminal.
Yeah, it's cool.
It's really comprehensive. Okay. So you are very far away from
zero.
From zero. So now I'm wondering whether your axis is probably all correct, but it looked like you had the right angle.
No, I think the axis is correct, but it's maybe the I don't know, the whole frame structure, the landing gear and everything.
It's not drifting. That's good. So the gyro calibration seems to be working. So let's do the accelerometer and calibration first. Then after the accelerometer calibration, then we do an offset. First of all, let's print out your accelerometer values, and see what we have. So for now, just instead of breaking this connection, I think you can just disconnect, so that we can use a terminal to just print out the accelerometer values. Understand?
Yeah.
So just disconnect this one, then let's go to the code.
We add them there, and then
No. We're going to print it out just like raw readings, not map.
Yeah, that's what I'm saying. But we have to then make changes to the telemetry Is,
Yeah.
Okay.
You don't use VS Code? Easier for me.
Really?
Yeah.
Ah, nice. No,
You don't use it?
no. I use this PID
Directly? Really? Wow.
Yeah.
Okay, that's something. Okay. So can we just copy this yeah,
This so
these
prints.
printing functions, just maybe comment it out, then we do a new one.
Ah, okay.
No, not the entire function, just the
The int.
and yeah, what's inside the function.
Okay.
Just comment
So,
and
so
copy
just
it,
this,
then
right?
yes. So that's then let me check what it is on my side, so that it will be easy faster for us. Copy it again, then we change those variables.
Mm-hmm.
So I think we need to see raw axis accelerometer x, y, z, and then we need to also see maybe gyroscope. Gyroscope looks good, but maybe we'll just see that once. Gyro x, y, z. Why not?
Okay.
So this so that there are 6. So let's start from the first one. So telemetry, tel, then sensor instead of filter.
Mm-hmm.
Can you just like delete up? Yeah.
Up to filter gone.
Dot. You should see sensor.
Yeah.
Sensor, yeah.
Mm-hmm.
And then dot. Let's see. IMU, yeah. IMU data. Dot. It is so long. I don't know why. It's like, yeah, you can choose what you want. Yeah, but you just choose X, Y, Z for accelerometer and gyroscope.
Okay. So that's
So that we see what we're dealing with.
Okay. So the ones that we're printing in telemetry viewer after the controller.
So the entire data is propagated to the controller, so you can still get it from the controller if you want.
Okay.
Yeah.
But this one that you want to see now, this is raw from the IMU straight before it.
Yeah.
Oh,
Yeah. Yeah.
oh.
But even the next one, we can check from the controller is the same thing. Provided it's not filtered. Yeah, to do the same thing.
Acceleration y x Okay. So what are we getting? What else are we getting?
Let's see the gyro at once while we're at it.
Okay.
So just copy the first line in down, then change the last to gyros.
Okay.
Gyro. Yeah. So this is good. Now we have to go into IMU.c. Because I think you're using my calibration values, right?
Oh, really?
So it's gonna
And I
spew
was
up
busy
everything.
looking for
Yeah.
any calibration data.
Go to something accelerometer rate or something like this. Just keep going down. If I see it, I will stop you. Read accelerometer, yep.
Read accelerometer. Line number?
No. 245.
245. Okay.
So this is it, yeah? Okay, so just comment out this all this 265. Just come to 267. This is where I applied my offset value.
Okay.
So let us see what your pure values look like. Can you copy it again to the next line?
This one that is here?
Yeah, you the entire block, yeah, to the next line.
Okay.
Because we have not assigned them, yeah. So just remove those offsets values. So that we're just assign the accelerometer value.
So
because
so
then we don't see anything in the data structure.
So just offsets only, not this. This one is
offset and scale.
Not scaling.
Offset and scale. Yeah.
Okay.
Because this is for my own sensor.
Okay.
The scale as well is for my sensor.
Okay.
So just want to see your own and see exactly what it has.
Okay. Yeah.
Okay.
So I hope these warnings are usual.
Yeah. I've not had time to look at all the warnings.
Yeah. Oh, I disconnected my. Just a moment. Yes. Cool. And put the com. What did I find as a com port? 8. So. And 11
Where's my?
Yeah.
Okay. I will also print from my end so that we can match and see that we have the same signs. You know. Quickly, let me do this. So you have data. Okay, good. Okay, so the Z looks good. We just need to calibrate it to be closer to 1. Then can you turn it around? Let's see what it looks like.
Okay, all right. I'll come and check it out.
Okay. Minus 1, ideally.
So this is on its side.
Upside down.
Upside down. Okay.
Yeah, so that the Z will not you know what I mean? So like minus this, it was like this. So now minus Z, so we need to calibrate this.
Henry.
Yeah, just now. I hear you now.
It's probably my cheap internet.
So this is what I have. That's fine. Let me quickly print mine as well so that we can compare.
Right. But say this one is the same at least. We just need to.
Yeah. So right now for me, my accelerometer Z is 0.98. Okay. I'll say it's good enough, and I'm printing 2 decimal places, so I think it's good enough. Positive, when it's like this, when it's on the table like this. So now I'll do this, and then we see the value. My value from minus side, it's minus 1.02. This is after calibration actually, and this is not perfect, but at least All right, then let's go back to the firmware.
Okay.
Let's go to the IMU.h. Yeah, if you can scroll down, we can see the calibration, the offset values. Yeah. So these are for mine. So for yours, look for the Z Okay, we need to calculate it actually. So your minimum was, if you can see the formula I wrote there, this to get the scale, 2 all over the maximum minus the minimum. So your maximum was 0.91 and your minimum was minus 1.11. So you can get your scale, and then you do the same for offset.
Okay.
Then we replace those values for your X and Y.
So
Sorry, replace those values for Z. Then for X and Y, I don't think we need a calibration.
no, yeah, true. So
Yeah,
0.91.
you can do that later, but for now.
Later or yes? Oh, the now.
No, I mean like you can do for others.
Okay.
What we need now is
the
the Z, yeah. Cool. That's the one that's.
So plus that was like 1 point what?
Your max was 0.91 and your minimum was minus 1.111. So
that's about 1.01.
Let's see, 2 divided by 0.1 minus.
The other way around. So that's I divided the wrong way up.
So it should be 0.99 for your scale.
Okay, so Z scale
0.99. Yeah. 99. Yeah. 0001. 01. Then the offsets the other way. 0.91 minus 1.11 divided by 2. So your offset is this right?
So minus should be negative.
So I'm getting minus 0.1 for you.
Minus 0.1.
Minus 0.1 for you, yeah. Okay. So if we go back to the .c, we just apply only the z-axis.
We go to the IMU okay, here.
Yeah, then apply just the z-axis. But I think I know what your actual problem is.
Oh, really? Okay, so the XY remain as is.
Yeah, we can just replace only the z-axis from the one above, just from the one above, and copy it. Yeah.
Copy that. Just to remain with your values. Just like that.
All right, good. Okay, so let's go to the filter.c.
Filter.c?
Yes. Man, some will be so confused in this firmware without any guide.
But I think we can create guides as you go. I think I noticed a lot of things you just realize along the way. Even PCB, there's some things. Iteration 1 was shitty. I'm going with time. You realize there's a lot of things you're realizing.
Yeah. So let's go down. So this is the filter.c. So this is where I think your problem comes from, 93 and 94. I'm already applying my own offset calculated. So you're using it. So you should not do that.
Okay. These ones here.
Yeah, so just make them 0. Can you go to the definitions and make them 0 for now for you? So let's see what your values actually are.
Okay.
No, just make them 0. Comment them out.
And which one? This one is right.
Yeah. All right, so can you go down now? Let's see, I think that's all. Now let's see what your angles look like. That means you now have to print.
I print what we were printing before, right? This same.
Yeah. let's print the angles.
Okay.
Telemetry C, then we print the angles
Okay.
instead of this. Then if we see that they're reasonable, then we can go to the telemetry viewer later. Because it's a lot of work to do that, to fix the table.
The angles, you mean? Not.
Yeah, just we want to print the row and the pitch now to see what they look like now. Now that we've done this.
All right. So.
Oh, okay. You want to see? Okay, wait. You want to see the Z-axis to see that it's calibrated, right?
We'll just check how it looks like.
Yeah, let's see it. Yeah, before we change it. Yeah. Okay. And also, when you start up the drone, the gyro calibration is done, and it should be stationary for maybe, I don't know, a few seconds.
Okay.
Yeah, so that it can take some values and then take the average. So when you turn on power on the drone, it happens before the LED comes on. So if the LED is on, then the calibration is already done.
Then the what? The calibration is done.
So if the LED is already on, then the calibration already finished.
Okay.
The gyro calibration already finished. Yeah. So it's not easy to teach online. Record something and honestly, a live teaching session will be a lot easier because I'm not very used to the camera and making recordings at the same time as trying to teach a technical topic. But let's keep going. So I'm trying to do a live section online for some maybe 25 people, right? That already have a drone ready
exactly
for debugging.
That would be easier.
Then if I can get most of them to hover, that would be a good one.
What's happening? The motors are beeping. Down yeah?
What did you say?
I'm saying I cannot see any values being printed in the serial console.
Okay. Maybe you restart the
maybe I just
PuTTY.
restart it. Yeah, you're right. Can I restart the session? Okay.
IMU not found.
Yeah.
Go figure. Okay, what's happening? I just power cycle it. Let's see. Did you add the 3.3 ohms resistor to the IMU?
No.
Okay, I think that will help later on.
That is on the VCC.
To the clock and data line.
The pull-ups.
Yeah.
Oh, really?
So you're looking good now. You have 1.0, right?
Oh, yes.
Yeah. Very nice. Okay, so we have confirmed the calibration is good. Then we can go and print the other thing.
Okay.
Yours is even better than mine. Mine is like 0.98. Oh, almost there, but yeah.
So we comment this out and we uncomment the earlier one, right?
Yeah.
And I cannot hear you, Mr.
I can hear you too. Oh. Everything is closed. Can you hear me?
Yes, now I can hear you.
Okay, fine. All right, so have you flashed the new firmware? Okay, what are we seeing here? Aha, something looking, well, looking good. 0.6 is very close now to 0. You see, this is good. 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 So now we can. Well, this is your minus 1.5.
This is what? Well, this is what?
That should be your
pitch.
Yeah.
Pitch, sorry.
So your row is reasonable. With just the tilt, we're fine, but your minus 1.5.
What do you have?
1 point. So because I have, so it's actually, is there anything under your table, under the,
There's
anything under?
I have this self-healing mat. No, sorry, I was standing on a cable.
Yeah.
But there's a self-healing mat. That's it.
Looks like a permanent offset. Yep. So -1. Can you move the pitch? Let us see how you look. How the angle looks.
I move there.
Pitch the drone. Pitch the drone.
Okay. All right. I'm pitching positive X direction.
Are you doing it so slowly?
Yeah, very slow.
Okay. So
I can move it.
then drop it to 0. Yeah. Okay. Then do for row. Let's see. Do for both directions. Let's see. So for the row, when you let me see my positive row. So using this, right? So if you roll the drone, if you lift 3 and
4.
3 and 4 up, that should be positive, right?
This side.
Yeah. If you lift 3 and 4 up, positive, right? Then the other way, it should be negative. Yeah. Okay. Then for the pitch, let's try the pitch. If you lift, how does the pitch work again? This is this. So, was it this way? I think, yeah. If you lift the back up, that's positive. 2 and 3 should be positive. It's negative.
No, it is negative actually.
Okay, why? Let me see.
So lifting this side.
Is what?
Is
it positive for you or?
Positive, I think.
Positive.
Let me see. So.
If you lift.
Yeah.
Okay. So if you go to the folder and then look for docs, the QuadFS folder and look for docs, you can see the convention. So that I use, so it's easier. Where have you kept it?
So docs.
Yep.
Okay. Yeah.
Doc. Yeah. Then convention.
Okay.
Last one.
I see.
Okay, then look for pitch here. Positive is up, as you said.
Okay.
Then negative is nose down. Yeah. All right, so that's good. You are good. So probably it's actually so it doesn't move from here, so I think it's fine.
And I have some questions, Henry. So
Yeah.
these values for completely flat surface, what should the first one is raw, right? What should the raw be? The first one is raw.
What should it be?
The first one is raw, and the second one is pitch. So what value should this be on a completely flat surface when the raw is 0 and the pitch is 0? Should they be 0 or should they be? They should be 0, right?
They can be 0, but I don't think so, because you don't the way you have mounted your IMU is probably not exactly 0. Yeah, you've mounted it with so there might be some offset there. So this is what we want to remove by this calibration and this other calibration I told you. If we go to the document, the
one that I opened already.
No, the other one. Or if you have the Git open, go to the Git, and then we look at those tables. Then we do the remaining one. And then if we apply it, we're going to remove that IMU tilt offset. Yeah. So let's see number 2. So the IMU mounting offsets. This is what we need to do now. To determine the IMU mounting offset correctly, a table of surface may not be perfectly leveled. The measured angle therefore contains both IMU offset and the surface tilt. Okay. To calculate the IMU offset, you place the quadcopter on a surface, mark the position, rate the row and the pitch, call that A, rotate the drone by 180 degrees, align the 4 arms with this marked position, read the same angle again and call it B, and calculate the offset A plus B divided by 2. Okay, so you have the drone right now. So can you just in this position, so it's like this, unless on the table, right? No, maybe I should face you. It's tricky, yeah. The
you have
point
to
of
you have
view
to move a little bit backward so that I see more
or forward.
More of the drone.
Okay, yeah, it should be it. I was
like
taking it into my phone camera. Okay, so in this position, right? Assume this is the table, it's on a table. So you take, we record the row and pitch value here. Then we turn it like this, such that this part faces me, right?
Okay. Okay. I see.
Try to make it the same spot as much as possible. Then read the row and pitch again. Then we call that D, and then we calculate in place. Yeah.
So here, right here. So A.
So for A, like you have row and pitch. So for the row and the pitch. So for row, your A is 0.45, and for pitch, your A is minus 1.55.
Okay. And for B.
Minus 1, right?
Minus 1.55.
5 or thereabout. Yeah.
I'll write it 4.
Then
I turn it around 180 laterally.
Okay. Yeah. So then we calculate, see what B is. Try as much as possible to have the quiz on the same locations.
I've marked it. 6.
And what do we have?
I have to remove them.
Did you mark it before?
Yeah, I've put the writing on the table.
Then we need to check the values again.
So
because they have changed very much. What did you do?
No, I've just turned it to 180 degrees on this.
Oh, really?
On this exact same spot I marked.
B is now for row B is now 0.75.
0.7.
And for pitch B is now 0.1. I would say 8. Yeah.
0.18. Yes.
Okay. So your IMU offsets for row is 0.45 plus 0.5 divided by 2.
0.5 plus 0.75, right? Over 2.
Yeah, divided by 2. And then for pitch, we are having. I think your table contributed to this.
Straight away,
the angle is so different. the values when you turn it 180.
Especially the one that moved from the negatives to.
Yeah, so it's 0 minus 0.685. What did you get?
0.18 over 2. So 0.45 plus 0.75. This 0.6 for one of them for the raw. And
Okay. A good test would be after we apply the offset, right? Then we come back and do this measurement again. It should be 0 or close to 0.
Okay. So one is 0.6, one is minus 0.
So the row is 0.6.
Yeah, row is 0.6. Pitch is
and the pitch is minus 0.685.
Yeah, 0.68 for me. I took the A for pitch to be minus 1.54.
Okay. Yeah. Then let's go to the firmware and just put those values.
That is IMU.
These are the things I cannot do from here.
Yeah.
I cannot do automatically, right? So someone has to do them.
Yeah.
So we need to go to the filter.c.
Filter.c. Okay, yeah.
Yep.
To the top, right?
So now we have your own values. We can now put them in.
Okay. What did I do? Not have a comma here.
How did we get away with that?
Strange. That's strange. A semicolon.
It doesn't complain.
So this is the row. It's 0.6, right?
We don't need the semicolon because it's a definition.
Sorry.
So the other one was the problem actually.
0.6 and minus. Oopsie. 0.6 for me, 68. Cool. Okay.
Then F, you can add the F, right, for floating points for both of them. Okay.
My table is so tilted, yeah? Okay.
Then scroll down, let's see what it looks like. If there was any change made.
What do you mean?
Okay, then we are good. So now let's flash it again. And then let's repeat this experiment. It should be close to 0. And you mark it, right?
Yeah,
so
yeah.
Exactly.
In fact, let me go back to what we start with, so that.
But yeah,
you know what I mean, right? Like right now it's facing me because of the experiment we're doing, but you should face.
Yeah, we need to do the experiment again. Get A and B, divide by 2, and see that it's close to 0. If that is true, that means we've removed the IMU offset. And whatever remains is just the surface offset, which does not really matter.
Okay, so
okay.
What?
Okay, let's do this. Let's calculate it again. You have your spots, right?
Yes.
So now we have 1 and 1.05.
What?
And minus 2.17.
So.
And then move them again.
You've taken note, or let me just take note also.
Yeah, take notes. Yeah, take notes.
1.0. I don't know what value you took. And then pitch minus 217. This is crazy. Okay.
Then turn it around.
So we have max spots and
Was it the same spot you used for the experiment?
huh?
Okay, let's see.
Yeah.
It did not change.
No, it did. At least the
Now it's 1.4 now.
1.4 and the other one has gone to
1.4.
minus
And this
0.
one is minus 0.48. So there's something not good because this will not. This will not give you an offset close to 0. All right. A plus B divided by 2. Nope. Maybe we have to subtract these values instead of adding them.
Yeah.
I probably already applied it to mine. You know what I mean? I mean, like in the code. Can you go back?
Okay.
Go to the code. I'm thinking maybe I already applied it to mine. Can you scroll down? Okay, so let's think about it. So the dot row is the entire thing, right? And if you want to remove it, so I think mine was a minus plus. That's why. So I think we need to use a negative here. So you get what I mean? To remove the offset from the row.
That we're getting.
Since I already applied my own, that was why. And then I have to make a note of that. So instead of plus the offset, can you do minus the offset?
Okay.
You get what I mean?
This line 93, right?
Yes.
Okay.
Yes. Because the value contains everything, right? It contains everything, the offset and the surface and everything. And now you want to remove this offset from it. Yeah. I must have already applied my own and just made it positive.
Okay. Let's try.
Okay.
Both.
Okay, let's do it again.
Let's see.
Then let's repeat the experiment. Because the values looks like they doubled, increased. So that's also a giveaway.
Let's see. Where we go from here. If it works with a minus, then yes, I'll take the kid to bed in a happy man.
Okay. So now we repeat the experiment again.
Okay.
So A is 0.13 or 1214 for row and 0.8 for pitch. Okay. So let's turn it 180 degrees and see. I should be saying minus. Yes, this looks good. This looks better than what we had before. Minus 0.23 minus 0.84. Yeah, I would say we're close to 0. So if you do the math, it's very close to 0. So now you have removed your IMU offsets. Yeah.
Right.
So I can see you're already tired. So at this point, these values are just the, so what you have made now is a spirit level. So these values now is telling you the tilt of your table right now. Yeah. So how tilted your table is. Yeah. So you can take it to any surface, and whatever angle you get, that is the tilt of that surface. Yeah. So maybe next time we can see what the IMU, oh, we can actually see it now, right? What the PWM signals look like. If they are reasonably close, yeah, we can see, okay. Yeah.
You want to use this, or you want to use telemetry view?
Yeah, let's use this just to be fast, yeah. Okay, so
these are
pretty close.
Are way better.
Let's see,
way better. Yeah.
Nothing far off. Then give it a throttle. Let's see. Before the integral kicks in, let's see what we have.
Yeah, these are way better.
Reasonable.
These are, so this is good now, because the differences were let's say a difference of 400 in the units between maybe one motor and the other in the PWM signal. So this is good.
Yeah, because of this, you were using my own values, and yeah, of course.
And so okay, all right. Though I have to take note for me of what we that we subtracted here, not adding.
Yeah, subtracting. I already applied it and then just put the definition there.
Okay.
Yeah. So for you now, what I did is this now. So instead of putting the minus here, I added the sign in the definition. You understand?
Sure. Yeah.
Yeah. So that was what I did, which is not so good.
Okay. Cool. All right. Perfect then. Yeah. Now I can sleep now, because these are very close. These are in the same orders of magnitude.
Yeah. So
just a short video to show the raw and pitch angles, the PWM values after having calibrated the sensor. So what we have on the left, we have raw in red and pitch in green. You can see they're close to 0. This is after the calibration. And on the right graphing, we have the PWM values 1 to 4. And so right now, the drone is not armed. You'll see the PWM signals once I arm it. So right now, armed, and you can see the values here. So red, green, blue, and I don't know if it's purple or pink. Those are showing us the PWM values around same orders of magnitude. And if I throttle up, this is 50% throttle, and then 100%. You can see the values. They're still in similar ranges compared to before, when there were some motors that are kicking in harder than the others. And then I throttle down completely to the lowest stick position. And on the left, we have raw in red and pitch in green. So if I pitch in the positive, in the negative X direction, and then if I pitch in the positive X, and so in my configuration I have motor 4 and motor 1 higher than motor 3 and motor 2. So this is pitch in the positive. And if I raw in the positive Y, so I have motors 3 and 4 higher than motors 1 and 2. And if I raw in the negative Y, motors 1 and 2 higher than motors 3 and 4. And back to complete flat. And that is what I have for my raw and pitch, and the PWM values as well. We're reacting here. So